Welcome to my channel. In this video we will try to repair those two boards from a gate opener. This is from the company Benica, Italian company, and this one from a Italian company. This board has a model of K570M. This is for a swing gate opener, and this is for a sliding gate opener. We will begin with the easiest one. This one has a problem. Here we have a exploded varistor, as you can see. Before replacing the varistor, I will check the transformer. I will use the meter to check the resistance of the winding. Here we have the primary side, and here we have the secondary side. So we have 264 ohm. The transformer is saved by the varistor. We can draw a part of the schematic. Here we have the fuse, primary fuse. Here we have the varistor, and here we have the neutral. And here we have the winding of the transformer, the primary winding and the secondary winding. Here we have the live, and here we have the neutral. When we have an over voltage, here we have the normal voltage. If the voltage exceeds the maximum voltage of the varistor, it will become as a short circuit. It will break, explode, and we have a huge current here that will blow the fuse. When the fuse is blown, it will save the transformer. Now I will replace the varistor. We can add here some fresh solder. I cleaned the place of the outlet varistor, this excluded one. Now it will be replaced by a new one. I will put the reference of the new varistor. It's tiny one. 07. This is 07 D 271 K. So this is the newest varistor. It can handle over 270 volt, I thought, the maximum voltage. So I will put the new varistor. I will solder the two legs here. And we will check the fuse to replace the fuse. This is the cutting plier. We will trim the excess. Now we will check the fuse. This one is blown. We must check the amperage. This is 100 milliamp, tempered 100 milliamp. I will use this box. We will try to find the 100 milliamp. So 125, the first one, it will be okay. I must check with the magnifier. So this one is 125 milliamp. We must use the holder. The holder of the fuse. Oh, this one. I must put fuse here. I will check the other fuse if it's okay or not. This one is okay. This fuse is for the tow motor, tow actuator to open the swing gate. And this 100 milliamp, this is only for the transformer which power the logic circuit here. So we have only the varistor protect only this one, protect the transformer, and this fuse protect the tow actuator. We must put here the label. Now I didn't bring with me the, it's okay. It's not a connector. We will try to power this board and see its life. I will check. I will use this screwdriver. So here we have the life and here we have the neutral. We will see only if we have something on this LCD connector. So I will use this to protect if it will be exploded. We didn't sure if it's okay or not, because the varistor usually they explode if we have a over voltage. Now it's okay. We have here the version 1. Oh, I am sure that the problem will be here. We have some smoke. So this varistor is not rated for 240 volt. I will check for another one. So the varistor exploded because it's not rated for 240 volt. Here we can see 7D 271 key. If we can see the data sheet here, we can do a zoom. Here we have 271 key. Its RMS is 175 volt RMS, or we have 240 RMS. We must use this one, the 7D471 key, which is rated for 300 volt RMS. I will use this used one. It's from a AC unit. It's properly mounted with this rubber to englobe the explosion. If we have a over voltage, I will try to desolder this varistor. I replaced the varistor. Now I will replace the fuse. I will grab the fuse box. I will replace this one, 125 milliamp. I hope that the transformer passed the last explosion. Now, of course, I will usually use this goggle, this protection goggle. We will do the test again. So we can see here that we have the board functioning. We can access the menu. Here we have the parameter. Here we have the logic menu. Here we can access to the radio to program the remote control and to return to the main menu. We press those two buttons together. Now we will see the other board. I will remove the two power cable. I will switch to the other faulty board. This one worked for 1 or 2 hours, and then it refused to receive the signal from those remote control. I will test those remote first. I will grab this breadboard. To test the remote control, I wired a small receiver with the same frequency. I will use this power supply. This receiver works with 5 volt. I will grab my bench power supply. Here we have the 2 leads are soldered here. In the other side, I will adjust the power supply at 5 volt. I will connect the 2 power cable. We can test. We have a lot of signal here. It's okay, it functions. You can see here that we have an output LED with this resistor to check the transmission. You can see that this remote work, and this one transmit the signal. Now I will power the board. So this board, here we have the neutral and the live. I will solder 2 wires here to test the. I will solder those 2 wires here in the live and the neutral. this board is controlled by this peak microcontroller. Its reference is, we will see the reference, 16F876A. It's rare to find a peak microcontroller in an appliance. I grab the oscilloscope with this Hameg probe. Now I will check if there is a voltage output signal from this circuit. I will search for the data sheet. I must enter usually this code to download the, so it's downloaded before. Now we can see if there is a schematic here for the output. Is pin 25 data, so we must see if there is data in the pin 25. Pin 25, we will see how many pin it has. Always in the end of the data sheet they put the 25, so we have not this one, this one, pin 25. So 25 is here before the fourth from the upper side. This is pin 1 and it has 28 pin, so we must see at pin 25. I didn't find any output from this circuit, but when testing the board I found that this crystal is functioning okay. We have here an oscillation, but with this crystal we didn't find any oscillation. So maybe the problem is with this quartz. This quartz is connected to the receiver chip here. We have here the quartz, as you can see, this one, maybe this one, crystal oscillator. So I will use another receiver. I didn't find any quartz with the same frequency. I have not one. I have 12 megahertz, 20 or 6, but this quartz has another frequency set here. You can see here, if we can zoom here. So it has 13.2256 megahertz. Also, I didn't find any signal in this filter. This is the intermediate frequency filter, 10.7 megahertz. We haven't any signal in the output. So I will use another receiver. It will be connected to the microcontroller. I will use this receiver. I will connect this receiver to this microcontroller, PIC microcontroller. Now we will try to reverse engineer this board. I did some tests and I found that this transistor is between the microcontroller and this receiver, high frequency receiver. So we have here pin, we have the output at the pin 25. So we must of course draw our transistor. We have here 3 pin. So we have pin 25 here. 25, it's connected to either this transistor or a resistor connected to the transistor. It's connected to this resistor. Pin 25 connected to this resistor. So I will put the resistor and here our input. I will zoom on the part of the transistor. So here we have the transistor. So we have here the resistor. This resistor is connected here to this leg. So this resistor is connected here. You must see here we have the ground. This pin is connected to the ground. We will see this pin. Maybe it's connected to the positive. Here we can see that the positive of our receiver chip is 2, pin 2 or 7 or 14. So I will take pin 2. I will switch to there isn't a direct connection, of course, between this resistor, this transistor and the power supply. I will use the ohmmeter to test here. I will use the ohmmeter, as you can see here. So I will see if maybe this is the collector, maybe it functions as an open collector. I will see with the two. We have here a 10 kilo ohm resistor. So this one is connected to the plus VCC with a 10 kilo ohm resistor. We can measure the other resistor in the input here. Also it's 10 kilo ohm. So this works as an open collector. Maybe this is a PNP. This is the base, of course. Maybe this is the collector and this is the emitter. I will check with the diode. So maybe this is the base. So if we can do some test here. .6 and 0.6. So this is the NPN transistor. So this one is NPN transistor. Here we have we can, from this drawing, go to the schematic. Here we have a transistor. Here we have a 10 kilo ohm to the plus VCC. This is 10K. This one 10 kilo ohm. And the emitter is connected to the ground. And this is the output of the data. Here we have the input. And here we have the output. Now we will check the output is connected to which pin in this microcontroller, this big microcontroller. So here we can use our meter. Now I will put this probe at the output. The output is here. This is the output. I will check which pin in this microcontroller. It will we will have a sound if we found the pin. This one, this pin. Now we will see which pin is connected to this transistor. It's it's here. Maybe we will find the pin. This one. So we can count 1, 2, 3, 4, 5, 6, 7. 6, 7 here. 1, 2, 3, 4, 5, 6, 7. So this is the RB0. It's connected to this RB0. It's maybe they use the interrupt. It can be used as the interrupt RB0. So we must connect our receiver at RB0. But this transistor affects the signal. It inverts the signal. If we have here 1, we have here 0. I will see if so maybe I must cut from here and introduce the signal to this 10 kilo ohm resistor. I found that this trace is coming from the output pin of the receiver, this receiver chip. I will do a cut here. I will cut this trace, this one, in this position. We must use a sharp screwdriver to cut this pin. We have all 3 wires here. We will use, of course, a tiny antenna here. So we have here the ground and the VCC. This is the ground, so this one will be soldered here. The left one is the plus VCC, this one. And those 2 middle pins are for the output. They must be connected to this transistor via a 10 kilo ohm resistor. And we will see with the oscilloscope if there is data at the pin RB0 of the peak microcontroller. This receiver will work with the same frequency as this remote, 433.92 megahertz. Now I will power the scope and this board. And we will see at this microcontroller if there is a reception. This circuit is now more functional now. Where is the probe? Here we have the probe of the scope. I must arrange the wire. Now we will put the ground, the 4th one or the 3rd one, I didn't remember. The 4th one is the ground, the common, this one. I will remove this antenna. For the 433 megahertz, you must use 17 centimeter antenna. 17 centimeter wire. So RB0, I will check its position. RB0, we have 1, 2, 3, 4, 5, 6, 7. So we must count 7 pin. 1, 2, 3, 4, 5, 6, 7. This one. I will now try to send a command. We have a reception here. As you can see, I will use higher voltage. We will use 2 volt. You can see here we have a reception. Now I will try to program this remote. Finally succeeded to get a response from this board. You can see here I connected those probes as the second relay. So this receiver has the first relay which can command the gate, and the second relay that can command a light, for example. We will test here. You can see here that it's configured as a bistable, so it will close for a small moment, maybe 1 second. Now I will solder the 17 centimeter antenna. It will be soldered here at this shelf. We can do a test again, the final test. I hear the relay, so it's okay. So the configuration used here we have the schematic. So my receiver, the new receiver, which has here an antenna, is connected the output of the receiver, those two pins, then the middle pin, they are together connected here to this 10 kilo ohm resistor. And here we have the plus VCC for the receiver, the 5 volt, and here we have the ground for the receiver. So this configuration is okay. It will send the signal to the microcontroller. Now we come to the end of this video. Thanks for watching and have a nice time.